Okay, Assalamualaikum everyone. I will go directly for the example for homogeneous with separable method. Okay, so please refer to ebook of John Bird, exercise 181. So I'm going to select two questions. Okay, so I will show solution for question number 1 and question number 4. Okay. Okay, so I'm going to show question for number 1, the solution for question number 1, and also question number 4. Okay, so let's look at the question number 1. Find the general solutions given this equation. Okay, so let's see whether the solution is correct or not. Okay, probably the answer in the ebook might be getting a different form, okay, which is not correct. Okay, so I will write down the original equation. X squared equal to y squared times dy dx. Okay, so remember in the homogeneous form with separable, first one we have to transform the original equation into dy over dx. That is equal to q over p, and then we use substitution for y equal to vx, dy dx is equal to v plus x dv dx, right? So the question is x squared equal to y squared dy over dx. Okay, so first thing is to modify into the form that we want to make it. Dy over dx is equal to, okay, so this bring it to the other side. So then we have x squared over y squared. Okay, so then the next step is to use this substitution. Remember, we have need to transform y equal to vx. So dy dx. Okay, from this equation we differentiate. So we have uh, v plus x dv over dx. Okay, so the form that we have here, the form that we modified just now. Okay, so we have to change this here and this one for the left hand side. Okay, left hand side. Okay, so I'm going to write down the new equation as follow. Okay, so the transformation the left hand side is v plus x dv over dx equal to x squared over, okay, so if we have y equal to vx, so y squared means y squared is equal to v squared x squared, right? So everything here must be evaluated to the power of 2. So here we have b squared x squared. Okay, so you see that we can do cancellation here. So means that it can be simplified to 1 over v squared. Okay, so I'm going to write down again. So v plus x dv over dx is equal to 1 over v squared. We settle first for v, simplify. Okay, so this v is on the left hand side. We bring it to the right hand side. Then we have x dv over dx is equal to 1 over v squared minus v. Okay, so why we have minus? Because there is a positive here plus, so bring it to the other side will be negative. Okay, means subtract. Okay, so this fraction we combine. Okay, we combine in terms of v. So means that for this one we multiply with the denominator part. Okay, so this will be 1 minus v times v squared. Then we combine, they are having the denominator of v squared. So this one we open the bracket. So we have 1 minus v to the power 3 over v squared. Okay, so this one x dv over dx is equal to this one. Okay, so I'm going to write down into the new form. as x dv over dx is equal to 1 minus v to the power of 3 over v squared. Okay, so before I proceed, I'm going to explain again. Okay, so we have the original equation, transform it to the dy dx over q over p, okay? And then we use transformation y or equal to vx, dy over dx is equal to v plus x dv dx. Okay, so this one, we plug in into the left-hand side for dy dx, and then we plug in also the term for y squared. Okay, so the one in the box, in the blue box here, we see that the function in terms of y and x. So after we do new transformation in terms of v, x, and dv, dx, okay, so we see that the new form, there is no more y, okay, so everything is in terms of v and x. Okay, so the next step is to apply separable, but before we apply separable method, you are supposed to simplify the term, okay? Okay, so the one here, okay, this one is the one that we are going to proceed in the next step. Okay, I'm going to write down again. X dv over dx is equal to 1 minus v to the power 3 over v2. Okay, now at this step we use separable method. Okay, so separable method means that we allocate v goes to dv, x goes to dx. Okay, so this x bring it to the right hand side, same goes with the dx. So everything here for v need to bring to the left hand side. Okay, so the form that we get will be in here, v squared over 1 minus v to the power of 3 dv is equal to 1 over x dx. Okay, so here x, there is a multiplication here, times, so bring it to the other side, becomes becomes divide. Okay, so this is there is a division here, so change it to division to multiplication. That means that the form will be a different one. Okay, the top become the bottom becomes the top. Okay, so the next step we do integration, both sides. The left hand side we integrate with respect to v variable. The right hand side we integrate with respect to x variable. Okay, so it's easy to find out the answer for integration on the right hand side. Integrate 1 over x, we have ln x. Okay, so if you do not know, please refer to the integration formula list, okay, the table of integrations. Okay, the issues here is to do integration for the left hand side with respect to the v variable. Okay, so as I've told you in previous video, there's a method to consider. Let's look at whether we can use substitution. Okay, other method, if we cannot use substitution, then we look at the partial fraction. Okay, and then if the partial fraction cannot, then let's look at whether we can use trigonometric identities, but this function is not trigo identities, right? Okay, so there's no way to use trigo identities here. The last step is to consider is the integration by parts. Okay. Okay, so let's look at if you choose the substitution method. Remember that the purpose of substitution method is to make it our form of the integration much simpler, okay, after we substitute. Okay, so if we choose u is equal to 1 minus v to the power 3, okay, so we differentiate here du over dv is equal to, differentiate here, so differentiates. Okay, so remember differentiate, this is a constant, so means that 0. So this one, when we differentiate, then we have negative 3v power 2. Okay, so remember differentiation. Okay, differentiates. So we have v squared dv, correct? So so the form here we can write down as negative 1 over 3 du is equal to v squared dv. Okay, so this one is the substitution that we use for the left hand side. So means that the left hand side, we use substitution method. So the new form of the substitution method to integrate will be in terms of u variable. Okay. So I'm going to write down here. The left hand side, we proceed here. Okay. So the integration v squared dv we get as negative 1 over 3 du. Then there's a u here over. Okay, because this is our u, correct? Okay, so uh, the new form of integration of v will become integrate for u. This is much simpler. So remember the purpose for the substitution method. When we use substitution method, the form after we substitute must be something that is easy to be integrated. Okay. So the right hand side will be integration for 1 over x. Okay, so remains it. So the left hand side is easy to integrate, correct? Okay, so then we can do the integration directly as negative 1 over 3. We have ln u, okay, because integrate 1 over u is ln u equal to integrate 1 over x, so we have here ln x, okay, plus c. Okay, so change back u to in terms of v, okay. So we have negative 1 over 3. Our ln u is ln 1 minus v to the power of 3. So equal to ln x. Okay, so remember that our original function is in terms of v, right? It's not in terms of v, it's in terms of x and y. Okay, so we use here y equal to vx. This is the form that we transformed just now. So here we have v as y over x. Okay, so our form for v must be transformed back into y over x. Okay, so we have here negative 1 over 3 ln 1 minus v power 3. So here we have y to the power of 3 over x to the power of 3 equal to ln x plus c. Okay, so let's combine. This is looks like two different fractions. So if we can combine them, so we can write down like this. Ln x power 3 minus y to the power of 3 over x power 3. Okay, ln equal to ln x plus c. Okay, so in the first question, there is no initial values given. So this is the answer for the general solution. Okay, so this is our general solution. Okay, this answer is also accepted. Okay, no problem. So you can express here it's separated, or you can combine like this one. So there's no problem. So this row, the answer here or this one, both are accepted. Okay, so let's proceed to the other question. Okay, so we have done question number 1. Okay, so let's look at question number 4. Okay, question number 4. So this is original equation. Solve. So there's no initial values given. Okay, so this time I'm going to show on the new screen. Okay, so the equation just now, I'm going to write down the original equation. X plus y over y minus x is equal to dy dx. Okay, so the original equation is already in the form of dy dx, right? Okay, the only difference that your dy dx is on the right hand side. So there's no problem, just need to change it. Left to go left, the left goes to the right, right goes to the left. Okay, so this is our Q and P. So we use transformation here. Okay, so remember that y is Vx. Y must be transformed to do Vx, then dy dx change to v plus x dv over dx. Okay, so they choose for transformation, so this one must be changed using here v plus x. So we just write down like this, equal to x plus, so y, put it here, vx, so x plus vx over vx minus x. Okay, so we have another y, so y change to vx. Okay, see that there is a common factor. Okay, so this x can be cancelled out. So we have 1 plus v. For numerator, we have v minus 1, right? So x can be cancelled out. So we have this one. Okay, so we can write down like this, v plus x dv over dx, that is equal to v plus 1, v minus 1, okay, minus. Okay, so then next one, this v, bring it to the right hand side. As here, x dv over dx is equal to v plus 1 over v minus 1 minus v. Okay, so minus v we combine with this denominator. So we have v plus 1 minus v in the bracket v minus 1 over v minus 1. So open this bracket, times out. So we have v plus 1 minus v squared plus v equal to v minus 1. Okay, so we have v plus v, we have 2v. Okay, so this is equal to, I'm going to just write down above here, 2v minus v squared plus 1 over v minus 1. Okay, so the left hand side is over here. So I can just write down like this, x dv over dx. Okay, so at this part, we need to sort first. Okay, v goes to dv, x goes to dx. So this x must bring it to the right hand side. So everything on the left hand side, because they are in terms of v, bring it to the left hand side. Okay, so we have this form as v minus 1 over 2v minus v squared plus 1 dv equal to 1 over x dx. Okay, so remember there is an inverse operation. Okay, so x bring to the right hand side becomes divide. That's why here we have 1 over x. Okay, so this is the form that we will consider to proceed with the separable variable. Okay, separable variable means that we have sort this one according to v following dv, x following dx. Okay, so the one in the box here is the form that we are going to proceed. Okay. Okay, so we proceed with this form. V minus 1 over 2v minus v squared plus 1 dv equal to 1 over x dx. So left hand side we do integrate, the right hand side we do integrate also. Okay, the answer for 1 over x, integrate 1 over x, we know we will get ln x. Okay, so the issues here is to integrate the one on the left hand side. Okay, so let's try whether can we use a substitution method. Okay, so if we choose substitution method, remember the purpose of substitution. we choose substitution so that after we substitute the form that we are going to integrate must become simpler. Okay, it becomes complicated means that the method cannot be used. Okay, so if you choose, let's say u equal to 2v minus v squared plus 1. Okay, so du dv differentiates. Okay, this is dv. So we have differentiate here. Here we have 2 minus 2v. So differentiate 1, we have 0. Okay, so this can be factorized, right? As 2, take it out 2. Then we have 1 minus v. Okay, we can write down like this one also. Okay, we can factorize here. Take it out negative 2. If when we take out negative 2, so here we have negative 1, okay, plus v. Correct. Negative 1 plus v. If we just take out negative, so means that this is negative, so here will be positive. So you may check that this is equivalent. Okay, so when we open the brackets, times out, so we have 2 minus 2v, correct? This is equivalent. Okay, so du over dv is equal to negative 2. I just change notation. V minus 1, correct? Okay, because there is a v minus 1 in the left hand side for the numerator part. Okay, so we can write down like this one. Negative half du is equal to v minus 1 dv. Okay, negative half du is equal to v minus 1 dv. Okay, so for the left hand side, okay, so we use substitution method. So the form on the left hand side will be transformed to the form that is containing u and dv. Okay, so it can be written as integration of, okay, so v minus 1 dv is equal to here. So I can just write down negative 1 over 2 du. So then this means our u, correct? So here we have u. Then is equal to 1 over x dx. Okay, so after we choose substitution, the form that in terms of v becomes very simple. Okay, so we proceed with integration. Integrate here will be negative half ln u. Okay, is equal to, on the right hand side, we have ln x plus 6, the constant. Okay, so u change back in terms of what? V. So we have negative half ln. Our u is 2v minus v squared plus 1. Okay. You can use bracket or you can use absolute symbol. No problem. Equal to ln x plus c. Okay, so remember that just now we use substitution y bx. This is for the transformation. So we have v equal to y over x. So here our form for v change to y over x. Okay, so here we have negative half ln 2y over x minus y squared over x squared plus 1 equal to ln x plus c. Okay, so to proceed, I'm going to write down again this one on the new screen. Just now we have negative half ln 2y over x minus y squared over x squared plus 1 equal ln x plus c. Okay, so first thing is to cancel out this one. Okay, make it just 1. So to make it just 1, so this must be times with -2. So when we want to times -2, make sure we do multiplication for the left hand side and also the right hand side. Okay, so the left hand side and the right hand side will be multiplied -2. So we have ln 2y. So when we multiply here -2, this will be getting as 1. Okay, minus x squared. So here -2 outside ln x minus 2c. Okay, so this 2c you can change to, let's say, call it as e. Never mind, just change this one to e. No problem. Okay, because it's a constant, so means that we express it to a new constant, but the new constant we label using different variable. Okay, now let's look at on the left hand side. Let's combine as one fraction. Okay, the one in the bracket. So here we have ln. Okay, to combine, let's look at we combine with denominator x squared. So everything here, this fraction, if we want to make it the denominator equal to x squared, so we need to multiply by x. Combine, so we have 2xy. Okay, uh, first fraction times x over x. Okay, times x over x. So we have 2xy. So denominator will be x power 2. Okay. So then we have minus y squared plus x squared over x squared. Okay, so equal to negative. Okay, so for this right hand side, we can bring it follow here. So we have ln x power -2. Okay, this is by using rules of logarithm, right? This exponent can be becomes to the power. Okay, rules of exponent or rules of logarithm. Okay, so here you can use let's say call it as e. You can use other symbol for the constants, no problem. Okay, so if you want to use a, you can use it. But then don't use c. Okay, because we start with c. So choose new variable. Okay. So this one on the right hand side, it's also equal to ln 1 over x squared. It's the same meaning. Okay, it's the same meaning. Okay, so the left remain the same thing. Ln 2xy over x squared. Okay, so uh, if we want to remove this ln, okay, just remove it. So means that this ln, okay, ln means is a log base e, correct? So it's ln, the same meaning. Okay, so means that we remove this ln, so there will be e to the power here, correct? E to the power here. So this one ln will be cancelled out also. So then we have e exponential to the power e. Okay. Okay, so I will write down here as 2xy minus y squared plus x squared over x squared equal to 1 over x squared, and we have this is plus e to the power of e. This e, small e, means the exponential, right? Okay, capital E is the constant. Okay, so let's say this is e to the power e. Let's call it, let's say, ff. Okay, can we just change it to that? Yes, you can, because it is just a representation here as constant. Okay, it's not as the function of x or y. So e to the power of e is still constant. So constant change it to another new constant with the assumption that our f, the new constant f is equal to e to the power e. So no problem. Okay. So if again, if you want to change it, then you can change it. Okay. So then, okay. So finally, our form it can be written the left hand side. So remember that okay. So this x cancel out. You can times x squared. Okay, so you have times x squared and so on, correct? And so we can have it here 2xy minus y squared plus x squared equal to 1 plus what? We have f some constant right just now. So this one can change to another variable. Let's say call it as g. Okay, plus constant will be constant. Okay, so this is our final answer. So this one we call as the general solution. Okay, so I just want to remind all of you, if you have still not clear with the techniques of integration, please refer back to your previous notes of Engineering Maths 1, or you can also consider the John Bird ebook. Okay, there is some previous topics on methods of differentiation and integration for you to refer. Okay, so please recall back the methods of differentiation and integration so that you will get clear understanding on solving the methods. Okay, especially for integrations. Okay, so I think that's all. Thank you. Then we will see you in the next video.